Hey, what's up? Let's do some math today. In this video, we're going to talk about Pythagorean triples. And Pythagorean triples, you know what they are? They're simply just a shortcut. These are patterns that work for the Pythagorean theorem. A squared plus b squared is equal to c squared. And what they do is they just let us, solve problems much more quickly with the Pythagorean theorem, and are especially handy when perhaps you are not allowed to have a calculator on a math exam or a math test or some sort of challenge contest thing. And calculators are just simply off limits. These love to be, or people who write these things love to embed the Pythagorean triples into their problems. It can make things very tricky if you don't know them, but then also very attainable and achievable if you do know them. So again, these are just a series of numbers that work really, really well for the Pythagorean theorem. For example, the most basic one is what we would call the 3, 4, 5. And that's where you have a right triangle with side lengths 3, 4, and 5, where the legs are 3 or 4, and then the hypotenuse is 5. We plug it in. 3 squared plus 4 squared is equal to 5 squared. 9 plus 16 equals 25. Quite literally, 25 equals 25. So what I want you to take from this video is just a series of these Pythagorean triples and something else about them. So let's talk about more of these. So let's start listing them all out here. So we have the 3, 4, 5. We have the 5, 12, 13. We have the 8, 15, 17. We have the 7, 24, 25. And then a 9, 40, 41. These are the big five. Now, more often than not, if we had to say, actually, let's go to a highlighter. These are the big two. You'll see these variations a lot. And when I say variations, we can also take any of these and multiply them by the same thing, and it still holds true. So for example, we could take, let's go new color here, take this one, and we can times it all by 10. So I could say 50, 120, and 130. This all works because this is 5 times 10, 12 times 10, and 13 times 10. It's still a 5, 12, 13. And so that's the thing, is I can take any of these multiples, and if I just multiply them by the same thing, or any of these Pythagorean triples, and multiply them by the same thing, it works. And again, so what these do is they just are neat little shortcuts for helping us solve Pythagorean theorem problems very quickly. For example, let's take a look at some of these. So here I got 4 examples for us. So when you see some right triangles, you want to immediately look at the numbers and start thinking, and do I notice anything about these numbers? Are these numbers Pythagorean triples? And so, for example, when I see 9 and 15, I see something that is multiples of 3 and 5. So my next thing is sort of like a little question that's going on in my head. I'm going, 3 times, so this is 3 times 3. Would this be 3 times 5? And it is. So those questions go away. And so 3, 5, that means that this has to be a 4, but I have to times it by the same 3 here. And so my answer would be 12. So again, I'm looking at the numbers, seeing, hey, are these multiples of any Pythagorean triple combos I know of? Let's take a look at the second one. All right, 39 and 36. Now this was a little bit tougher, but it's very similar to the other one, where this is 3 times 13, 3 times 12. So we have is a 13, 12, 5 Pythagorean triple, but we just have to times this one by 3, and so that missing side length is 15. So see, I'm not crunching any numbers. I'm not using a calculator. I'm using these known set of numbers to help me solve some problems. All right, now let's take a look at this guy right here. Ooh, this one's tricky. So again, just kind of see, maybe do they share a common factor? And this one shares a common factor. Let's go new color. Of 2. This is 2 times 24. This is 2 times 7. Uh-oh, 7, 24, 25. We got to times it by 2, so my hypotenuse here is 50. Finally, I want to show you this could even go the other direction. Now, I'm not expecting you to look at this and be like, oh, I know which one this is right now. But after a while, and if you do a lot of these problems, you'll be able to see it when it goes the other way. So what this is, in disguise, is an 8, 17, 15 right triangle. But what we've done is that this 4 is 8, actually, let's take that back, 8 times 1/2. This 8.5 is 17 times 1/2. And so this side right here is going to be 15 times 1/2, which is, spacing, there we go, 7.5. So that will be the side length there. So the thing is, if we wanted to, we could get smaller. Or we could multiply by something a little bit more awkward, like 1/2, or we could go like 5.5, maybe to help to kind of disguise the fact that we're using a Pythagorean triple. But it is fair game, and it could still work. And you can then still use it to help solve some of these problems. So again, this is just a real short video about Pythagorean triples. They are shortcuts. All right, these are known numbers that work for the Pythagorean theorem, and they can just help you solve problems a lot faster. So take a look at these. Make sure you have them written down, and also remember that you can take any of these and multiply them by the same. If you multiply them all by the same number, they still work. So that's what that A stands for. Just kind of multiplying them all by some A, some constant multiple, and they still hold true. So good luck on your practice, and let me know if you have any questions.